So today we're going to start 12.4, which is properties of log functions, and we are going to start now. I think yesterday he finished 12.3, right? Okay, good. So let's see 12.4, products of log, etc. So let's share the desktop. Share. How about the attendance? Were you guys here when Dr. K was here? So everybody was sort of here? Okay. And you guys treated him nice? Oh, okay, good. All right. So 12.4 is properties of log function. So properties of log function. All right. So, where is my note? Hold on. I have it here. Okay. So the first one is product rule. This is log function. So it is called product rule. And it says this, log base A of mn, this is equal to log base A of m plus log base A of n. So log base A of mn is log base A of m plus log base A of n, okay? So the log of product is equal to the sum of two logs. So for example, express as sum and then simplify when possible. So simplify if possible. Right. So number one, what is log base 5 of 25 times 125? And then what is log base T of ABC? All right. So what would you do here? So on the first one, we're going to write it as what? So if I have product, then I have to rewrite it as sum of logs. So in this case, what will this be? Log base 5 of 25 plus log base 5 of 125. Okay. So do we know what log base 5 of 25 is? He didn't talk about that last time? No, okay. Okay, so anyway, this is what it means. You know how we could change log to exponent? Yes, you do know. He did talk about that, didn't he? Okay, but so if I ask you, so this is review a little bit, yeah. So suppose if I ask you, what is log base 2 of 8? This is the same question as asking 2, this is not equal sign, 2 raised to what number? Let me write it. 2 raised to what number? 2 raised to what number? Yields 8. So my question is 2 raised to what number will give you 8? To what number? 3. Is it 3? Yes, so this is 3. Or I could write it as exponent. So 2 raised to what number will give me 8? And what is the answer on the box? 3. Right? So, and if I ask you, what is log base 3 of 1 over 9? So what type of question am I asking here? What type of question here? What is the base? 3. 3 raised to what number yields or gives 1 over 9? So that's the question that I'm asking. What is log base 3 of 1 over 9? So 3 raised to what number will give me 1 over 9? What is it? Negative 2? Yes. So the answer is negative 2. Yeah? Simple? Okay. So this is basically 3 raised to what number will give us 1 over 9. So my answer here will be negative 2. Right? Now another question. What is log base 10? Log base 10 is just log of 0.001. So if I don't write down the base, what is the base going to be? Base 10, yes. Okay, so what is log base 10 of 0.001? 0.001. So this is log base 10 of 1 over, what is 0.001? 1,000. 1 over 1,000. So what's my answer? So then this is equivalent to asking what question here? What is my question? 10, right? That's the base of the exponent. 10 raised to what number? Gives or yields 1 over 1,000. So what is your answer here? 10 raised to what number gives me 1 over 1,000? Yes, negative 3, right? Okay, so my answer is negative 3. So that's going to be your answer here also. Now, let's go back to our original problem. What is log base 5 of 25? 5 raised to what number gives me 25? So what's my answer? 2. Does everybody know this is 2? So I am asking 5 raised to what number will give me 25? And the answer is 2. Now, what is log base 5 of 125? So what question am I asking here? 5 raised to what number it gives me 125? 3. So are we okay? So 2 plus 3 is 5. Yes. Okay. Good. Yeah. So this is yeah. Now, good. So I hope you should do this. Log base 5 of 125 is 3. Log base 5 of 25 is 2. What is log base C of ABC? Log base C of A plus log base C of B plus log base C of C. That's it. You can't do anything else, right? Okay. By the way, the other way that you could do, so there are many ways to find the log. So suppose I say log base 5 of 25. This is another way. So another way to evaluate log. So this is one way. So if you want another way to evaluate log, you're just going to use this. Log base 5 of 25 is 5 squared. So what is log base 5 of 5 squared? 2. Did he talk about this property? Log base A of A to the x is x? No? Okay. He didn't? Okay. So it will come later. So forget about this. Yeah. So as of right now, this is how we find log base 2 of 8 is 3. Yes. What about the second example? expressed as a single term. So expressed as a single term. What about if I have log base A of 7 times log base A of 12? What is log base A of 7 times log base A of 12? What would this be? How do you write this into single term? Yes, log base A of 7 times 12. What is log base A of 7 times 12? 7 times 12 is 84. Yes, good. Yeah, so the first one is expressed as sum. Here is expressed as a single term. All right. Now, this is called product rule. We also have quotient rule. So that's coming up next. All right. Oh, by the way, does everybody here have a cell phone? Anybody not have a cell phone? I was going to use Kahoot next time. Well, not tomorrow, but next week. So, do you know Kahoot? It's going to be interactive, and we need your cell phone in order to do it. And I'm going to give you a quiz on Kahoot. Okay, but does everybody have a cell phone? Does anybody not have a cell phone? You have to let me know, because otherwise it will be different. Yes? Everybody has a cell phone? Okay, good. And you know how to log into Wi-Fi, right?
Yeah.
Okay. So next week we will need it. Yeah. And I will let you know once I'm done, because I have to prepare. I cannot just use whatever they have there. Yeah. But it's going to be fun. Did anybody use it? I think so, right? In high school, yes. The second one is called quotient rule. Oh, that's something that I learned also from, and then there are other things. Yes. From my conference. Okay, so what is log base A of m over n? What do you think? If I have division, then what do you think? Yes, this is log, you should say log base A. Yeah, this is base A of m minus log base A of n. That's right. Yeah, good. Now, so this is called the difference of logs. So log of quotient. So log of quotient is equal to the difference of logs. Maybe I should write this. Okay. And then if I have, maybe I should write here, log of product is the sum of logs. So I just added this. Sorry, let me highlight it with blue. So that's the new one that I. Log of product m times n. That's the product is equal to the sum of logs. Oh, what's that? Can you turn it off, please? Yeah. And then the other one is log of quotient is equal to the difference of logs. So this is minus, so that's why it's the difference. This is plus, that's why it is a sum. Yeah? Are we okay so far? Yeah, okay. So now, what we want to do is express as the difference of logs. All right. So now, number one, log base 2 of 53 divided by 17. And then number 2, log base 3 of 23 over 9. So this is not hard. Okay, so what is log base 2 of 53 over 17? Log base 2 of 53? Yes, log base 2 of 17. Yes, that's right. Yeah. So log base 2 of 53 minus log base 2 of 17. Yes. Can we simplify log base 2 of 53? No. What about log base 2 of 17? So we're done. Yes. Now number 2. This is log base 3 of 23 and then minus log base 3 of 9. Okay. Can we simplify log base 3 of 9? Yes. So this is log base 3 of 23. There's nothing we could do about it. But what is log base 3 of 9? 2. How do you get 2? That's right. But how? 3 raised to... Right. Yes. 3 raised to what number gives us 9? Right. So that's why this is 2. Are we okay? All right. What about if we want to express it as a single log? So let me go here. So express as a single log. All right. So number 1, log base b of 36 minus log base b of 4. And then log base a of 5 minus log base a of 13. All right. So then what? So number 1 would be what? Log base b of 36 divided by 4. So can I simplify 36 divided by 4? Yes. That's right. Okay. Log base b of 9. How about number 2? Yes, log base, I use a here. Yeah, that's fine. 5 over 13. But we cannot simplify 5 over 13, right? So we're done. Is it easy? Okay. So the next one is power rule. So power rule. Oh, so you have product rule for logs, quotient rule for logs, and power rule for logs. So log base a of m raised to the p. All right. So if you have log base a of m raised to the p, you could actually bring the power down. So this is, so p times log base a of m. All right. Okay. I don't know how to say it. Hold on. Log of power, something to the power is equal to. Let me see how we say the word. Okay. Give me a second. So 12.4. Okay, 12.4 properties of log. Okay, yes. So it says this: the log of a power of m is the exponent times the log of m times the logarithm log of m. So if you have log of power of m, so you can bring the exponent down. So we will use this a lot. So I'm going to say that this is used to simplify exponential equation. Exponential equation. Okay, and the difference of log and the other ones are for, so for number 1 and 2 are for log equations, and then this is for exponential equations. So 1 and 2 are for log equations. So we'll know later. So for example, express as product, so not as exponent. Okay, so number 1, what is log base 7 of a cubed? And then number 2, what is log base 3 of 5th root of x? All right. So we just bring the exponent down. What is the exponent of a here? 3. So this is 3 times log base 7 of a. Yes. 3 times log base 7 of a. Okay, now do you remember what this one is? What is fifth root mean? Yes. So this is log base 3 of x to the 1 over 5. Yes. So the power is 1 over 5. So what can I do with the 1 over 5? Bring it down. So bring it down. So we just bring it down here, right? So what do I mean by bring it down is just put it there. So this is 1 over 5 times log base 3 of x. That's it. Is it simple? So if you have a power of m, then you can just bring it down. Now, the next one is number 4. This is cancellation properties. And then we will talk about the review from yesterday. Yeah. So number 4, are you with us? So let's see. Number 4, so the 4th property is called cancellation properties of log. So cancellation properties, there are 2 of them. Okay. So the first one is log base a raised to the a to the k. This is k. So why? A raised to the what gives you a to the k? And the answer is k. So if I change this, if you change this to question, then you're going to be asked a raised to what number? Gives a to the k. So what is the answer to my question? A raised to what number gives me a to the k? K, yes. So this is called the cancellation property. Log base a of a to the k is k. The second one is what A raised to the log base A of K. This is also equal to K. Right? How do I prove that? This is using the you have to rewrite it. This is an exponent. You have to rewrite it using log. Yeah. So this is an exponent, then you have to rewrite using log. So these two are the two properties. Now this one, the second property, cancellation property. This is used for solving. So this is well, maybe let me use red. Used for solving log equation. Log equation. So this is cancellation's property of log. So A raised to the log base A of K is equal to K. Yeah. So two properties. Now these properties follow from property 4. Yeah. So this follows from property 4. Property 4. All right. What about if I have log base A of A? What's my answer? What is log base A of A? Maybe I should say this is A and B here. This is A and B. 0, 2. What is log base A of A? What is it? It follows from this property. Property 4A. What's your answer? What is log base A of A? Any idea? 1, yes. So why? So this is 1. Why? Because, yes, log base A of A, this is equal to log base A of A to the first power, so this is equal to 1. Log base A of A is 1. Now the second property that follows from property 4A is, what is log base A of 1? Log base any number of 1. What would that be? Log base any number of 1. Come on, you guys know this. What is it? No? Okay. 0, yes. Why is it 0? Because log base A of 1 is equal to log base A of A to the 0, which is, what is log base A to the 0? 1. Or you could use the other question too. A raised to the what is equal to A? So the other thing is, you could also say there's many more. So A raised to what number? So suppose I leave this blank. Yeah. A raised to what number? Gives A. So what is the answer to this? What is your answer? A raised to what number gives you A? 1. So that's why this is 1. Yeah. Here there's another question. A raised to what number? Yield 1. What is your answer? A raised to what number gives 1? 0. Yeah. So that's why this is 0. So either way, are we okay so far? Yeah? Okay. Let's see, what other properties do we have? Nothing. So let's use the properties together, huh? Yes, are we ready? Let's use the properties together. Okay, let's see. Okay. So using the properties together. Okay. So express in terms of individual log. Individual log of W, X, Y, Z. So you cannot have the power. Yeah. So A, log base A of X, Y squared over Z cubed. And then number 2, or not, B, is log base B of W squared X cubed over Y squared Z to the 4th. So let's do this first. All right. Okay, so how do we write this? Log base A of X. Yes. And then this is product, so it is what? Plus log base A of Y squared, but do I put the square here? No, I'm going to bring it down, right? So instead of Y squared, what do I have? 2 times, yes. So, right. So it's supposed to be Y squared, isn't it? But I'm going to put it as 2 times log base A of Y. Next. Minus log base A of Z cubed. But what do I do with my cube? Bring it down so it becomes 3. Okay. So I'm going to erase this, okay? Z cubed. So it's minus. All right. Are we okay so far? Easy? Okay. Now can you do B? Okay, and then C. Let's see. Log base A of 4th root of X to the 8th, Y to the 10th over W cubed Z to the 5th. So basically on C you have to change them into exponent. 8 over 4, 10 over 4, right? Because that's 4th root. All right. So it's not that bad, isn't it? Yeah. Okay, so how do we do it? Or B? log base b of w squared. But I'm not writing the square. 2, yes. Plus 3 log base b of x. Minus 2 log base b of y. This is on the bottom. This is on the bottom. Yeah, minus 4 log base b of z. Yes. Yeah, so not plus, because this is minus, unless you put the parentheses, right? But no, when it's on the bottom, then it's minus. Yeah, so pay attention to this. Because it's on the bottom. B is on the bottom. Good. Now, what about C, the third problem? What would you do first if I have a radical? So we have to change it into exponent first, right? So this is log base A of what? 1 over 2? 8 over 4, right? Y to the 10 over 4. How about the bottom? W to the 3 over 4. Z to the 5 over 4. Yes. So can we simplify anything? The top one, so it is log base A of x to the 2 square. So y to the, can we simplify 10 over 4? 5 over 2, yes. Divided by, well, the 3 over 4 and z to the 5 over 4. All right. Now, let's separate the log. So how do we separate it? So how do we separate the log? How do we separate the log? 2 times log base A of x. Then plus 5 over 2 times log base A of y. Then minus 3 over 4 times log base A of w minus 5 over 4 times log base A of z. Yes. So the most important thing is to rewrite the exponents separately. Right? If you have radicals, then we rewrite the exponents for them separately. For each x, y, w, and z. Is it easy? Yeah. So now the next one, what we're going to do is express a single log. So this one is expressed in terms of individual log. Oh, by the way, I'm waiting for questions. No. I'm waiting, but nobody has questions? Okay, good. So next, let's see. Next is, what about if we combine? So express as single log. So maybe number 2. So express as a single log. All right. So A, 7 log base A of x plus 3 log base A of z. That's it. And then B, log base A of x squared minus 2 log base A of square root of x. So what would you do here? Log A. No. Log A. What is log A? Log A, what A? No, there's no log A. Log what A? Yes. Yeah, you have to say log base A. Because log base A, you know why? I'm very particular about that. You know why? Because if I say log base A, this is log with base A. And then it follows something else. But if you say log A, what is log A? This is log base 10 of A. That's why I was very particular when I asked you. No, it's not log A. Because if you say log A, which one are you referring to? The bottom one. Yeah, and they're not the same, right? Okay, so that's why I want to make sure it's quite particular. I asked you again. So this one, which one is this? Yes, log base A of, that's right. Okay. Times, or actually if you want, you can write this down, this is optional, plus log base A of Z cubed, right? Now you have sum of logs, then we have logs of product. I think this is a good note here. So when we say log base A, this is log base A, yeah. But I don't have space, so I have to erase this, yeah. So you guys know the difference between log A and log base A? Okay, good. I am glad. So this is log base A of, what is it? When I just want one log, x to the 7, and then, right. There you go. All right. Sounds good. Now, would you be able to try the B? And then let me give you two more. So C, okay. Log base A of 2x, so this is 2 times x, plus 3 times log base A of x minus log base A of y. And then D is log base A of 2x plus 10 minus log base A of x squared minus 25. All right. Okay, let me wait for you this time. Okay. So you want the test not tomorrow, but on Wednesday, right? Was it scheduled tomorrow, supposedly? No, you forgot? Okay, well, Wednesday is fine, but it will be close to the Chapter 12 test. Yeah, because we have a test tomorrow, and then Chapter 12 is the, yeah, it's okay, it's the following week anyway. Yeah. Okay, so are you guys done? So make sure the exponent is correct first. Like here, instead of 7 log base A of x, this is x to the 7th, right? Instead of 3 log base A of x, it is log base A of x, z cubed. So you're going to do the same thing. You have to have the exponent on each one of them. What about these? What is the exponent here? What is square root? To the half. What about if you multiply by 2? Then it cancels out. So it's just x to the first power. Right? Okay, good. So why don't you try it? Don't take too long. Because we're almost done. Yeah. And then we'll talk about common and natural log. And then we will talk about change of base formula. But Dr. K, I think, already talked about that. So, okay, 2-3 minutes. Who's not here today? So Angelus is here, Janri is here. Who's not here today? Jesus dropped, right? Who's not here today? Alfaro also dropped? Yeah, he has been sick for a while. Jose Martinez is dropped. What happened to those people? What happened to Alfaro? Sick. I think he has been sick. Jose has to work. And then Nestor dropped also. And Nestor, oh, we don't have too many. Okay, so B, what is this B? Oh. This is log base A of x squared. So this one, there's nothing to do here. Minus log base A of x to the what? What is the square root? 1/2. But then I have a square, right? Yeah, so this is log base A of x squared minus log base A of x. Yes. So then what? Log base A of x squared over x. Okay. Yes, that's right. Cool. Good. All right. Now, C. What about C? You don't know this one? Well, we distribute this, don't we? Yeah. Okay, then we know after that, don't we? So log base A of 2x. And then 3 log base A of x. Base A of y. Okay, now I need to make sure I have all the exponents here. So log base A of 2x plus, yes, minus log base A of y cubed. Yes. Now you could write it as a single log. After all the exponents are taken care of, then we could write it as a single log. So what is this? Log base A of 2x times x cubed over y cubed. Well, can we simplify a little more? 2x times x cubed, you could simplify. What is 2x times x cubed? Yes. So this is log base A of 2x to the 4th divided by y cubed. Yeah. All right. Oh, yeah. So this is this part. Are we okay so far? Yeah. Okay, good. Last one. Oh, this is easy, isn't it? So this is log base A of, what, can you do anything with 2x plus 10? No, right? So this is not equal to log base A of 2x plus log base A of 10, right? No. Right? So you can't write these, remember? So what can you do with this? Nothing. Yeah, well, there's nothing you can do. So log base A of 2x plus 10, because this is a plus. What about these? This is minus, so how do we combine those? Over x squared minus 25. Let's see, can we simplify or can we factor? Yes, the top one too. So log base A, how do we factor out the top one? Greatest common factor. 2 times x plus 5. Yes. On the bottom one? Yes. 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 There you go. All right. Are we okay so far? Good? Okay. Now, I am done with 12.4, which is properties of logs. So we have 8 minutes. So let's just do the summary. Yeah, and tomorrow we will start 12.5. Yeah. So tomorrow you're going to bring the sample test, right?
Yes.
And you're going to look at it tonight. Is that correct? Okay. So what homework do you want me to close tonight? Up to 12.3? Because I was supposed to close it on Sunday. Oh, okay. Up to 12.2. How about that? 11.9 up to 12.2.
Yes.
Up to 12.2. Yeah. Okay. And Wednesday we have a test. Chapter 11. Remember, chapter 11 is long, so you guys have to start studying. Yeah. What did you say? What happened? Yes, all chapter 11. So on Wednesday, you're going to bring the portfolio for all chapter 11, including 11.9. Yes, up to 11.9. Yes, 11:59 p.m. today. 12.2, but I think you did some, didn't you? Yes, that's what I thought. So actually, I should have closed 12.3 last Sunday on Sunday. 12.1? 11.9? Okay, so you want to do 11.9 now? I'm done with 12.4. This is 12.4. Let's do 2 problems from 11.9. How about that? Okay. Okay. So we're done. So this is the end of 12.4. So you want to do 11.9? Yes? Okay, quadratic inequality, or you're talking about quadratic inequality, right? Quadratic inequality. Okay, let me see. Some questions from the book. All right, so is it quadratic and polynomial or just quadratic? Chapter 11. And rational inequalities. So you want me to, you do have questions on that, right? Okay. So, for example, you have, let me see. Which one do you want to do? What problem is not clear? So suppose I have something like this. Is that what you want? X squared plus x minus 2 is less than 0. Is that what you want to do? X squared plus x minus 2 is less than 0? Is that what you want to do? Okay. So first of all, when you have polynomial inequalities, what you want to do is to figure out to have less than 0 or greater than 0. So one side must contain 0. So here, why do I need that? Because here I know that we want negative values, right? We want something that is less than 0. So we want something that is negative values, so the function values. If we graph, it's going to be below the x-axis. So did you do it using graph? Yeah. So we want negative, so we want something below the x-axis. Then what you want to do is solve this. So replace the inequality sign by an equal sign. So I'm just going to write by equal sign, something like this, and then solve. So x squared plus x minus 2 is 0. So then what would this be? Is it factorable? Negative 2 and 1. So what is this? X plus 2, x minus 1. By the way, you guys don't have problem factoring, right? Okay. So x is equal to negative 2 or x is equal to 1. So up to here is easy. Then you're going to graph on the number line. Now you have 2 points, negative 2, open or close. Open. And then 1, open or close? Open. Okay. All right. So this gives you the x-intercepts. When you set this equal to 0, this gives you the x-intercepts. So these are the two x-intercepts that you have. How does the graph look? Does it open up or open down? So we're talking about this function, f of x is equal to x squared plus x minus 2. This one, look at this. Open up? Okay, so if I graph, it's going to look like this. And I don't care the vertex or anything. Yeah, but I know the intercepts, the x-intercepts, they're -2 and 1. Now, this is how I look at it. If it's above the x-axis, the function is positive. So this is 0, this is positive. And what about if it is below? Negative, and this is above again, so this is positive again, right? So now, why do I put plus here and minus here and plus here? Do you remember? If it's above the x-axis, the function value is positive. If it is below, negative, and above again, positive. Now, which one do we want? Well, you look at this. That's why this is really important here. We want negative. So what is my solution? -2, comma 1. And do I use bracket or parentheses? Yes. Or if you use that builder, it is x such that -2 is less than x less than 1. Right? Okay. Is this what you're asking me? Which part is confusing? Maybe the...
Yeah, the way you explained it was confusing.
Okay.
You had like some more extra steps you weren't supposed to do.
Yeah.
You basically had to solve for every single point other than a given.
Okay.
Since you made a two, for instance, something like -3, -4.
Yeah.
Oh, so he does that point.
Yeah.
Okay, well, this is what happened, okay? If you have a quadratic function, you know how it is graphed. Is that right? But if my function look like this, which is that this is quadratic inequality, we know how it, what about if my function look like this? Okay, so let's just say x plus 3 over x minus 5 is less than 1. So here, do you know how this graph look like? No, you don't. That's why this is when you use the test point. But, you know, if you do have a problem, tomorrow we will discuss it. How about that? Okay? So we will do 11.9 and also your sample test. But can I ask you a favor? Can you work on your sample test? And then we will discuss more on 11.9. Okay? All right. Sounds good. So everybody should look at their sample test today. Yeah? Okay. Okay, guys, good. I'm so glad to see you back. Yeah. Okay. All right, so I promise you tomorrow we will discuss more 11.9. Yeah? Okay. Anyway, we're done with 12.4 logarithmic function, and tomorrow we will discuss 11.9 and also